45, we have one last problem where we are solving for x. In this case, we need to identify the angle relationship, and we can see that these two angles are what kinds of angles? Vertical angles. And vertical angles are always congruent. So we can set them equal. So we have 3x plus 2 is equal to 71. That means 3x equals how much? And so that means that x equals, very good, x is 23. Are there any more questions on solving for x? The first thing you have to do is identify the angle relationship. If you don't correctly identify the angle relationship, you're not going to be able to set up the correct equation. The next section asks us to write a rule to describe the transformation. So let's take a look at problem 46. I can see that t went from the top to the bottom, m went from the bottom to the top. So I'm expecting this to be what kind of transformation?
Reflection.
A reflection. And I'm just going to look halfway between them. I've got 1, 2, 3, 4, so halfway between them is going to be 2 on each side of the line of reflection. If I flip this top one over the line I just drew in, do I get the image at the bottom?
Yes, ma'am.
I do. So let's identify this. So we're saying reflection across, it's a reflection across what?
X-axis.
The x-axis. Very good. The reflection across the x-axis.
Thanks.
Now, I'm just identifying the primes here. I'm identifying the primes and I'm highlighting the original because that's a little difficult for me to figure out which goes with which. Okay, so it looks like our line goes through the figure itself, which is fine. Once again, we see that they've switched positions. M was on the left, now M's on the right. H was on the right, now it's on the left. So if they switch positions, that means we're dealing with what kind of transformation?
Reflection across the y-axis.
Well, it means we're dealing with a reflection. We don't know what the line of reflection is yet. But if we were to figure out the line of reflection, we would say, okay, there's 2 boxes between H and H prime. So halfway between that would be this line right here. If we flip over this line, do we get the image?
Yeah. Yes, ma'am.
Yes, we do. So that means it is a reflection across what?
The y-axis.
Very good. Reflection across the y-axis. Okay, on 48, did the vertices switch position?
Yeah.
They switched location, but did they switch relative position?
No.
No, they stayed in the same orientation to one another. So that means we're not dealing with reflection. What are we dealing with here? We're dealing with a translation. We could do words, we could do arrow notation, or we could do displacement. I'm actually going to do all 3 on this one. So we have a translation. Okay, to go from the original to the prime, what did we do first, Brendan?
-1. Go left.
So we went left 1, then what?
Down 1.
Then down 1. If we were using arrow notation, we have to draw in our arrow. Left is left plus or minus?
Minus.
Minus. So x minus 1 is down plus or minus?
Minus.
So y minus 1. And then displacement, we just put in what we did to each of them. So we subtracted 1 from the x, we subtracted 1 from the y. That's not the point -1, -1. It's telling me that I have to go one to the left and then one down for each of my vertices and then reconnect them. Okay, on 49. What do you see in 49? What kind of transformation does it have to be? Not transformation. Has to be a rotation. Okay, so for a rotation, we went how many quadrants?
One.
We went one quadrant. So one quadrant is how many degrees? 90 degrees. Okay, did we go clockwise or counterclockwise? Clockwise. About what? The origin. We went 90 degrees clockwise about the origin.